Hello, in this demo video, we will present a clever way of exploiting the infamous PwnKIT vulnerability discovered by the Qualys research team. PwnKIT is a type of memory corruption vulnerability in PwnKIT's, formerly PolicyKit, PKExec, a component for controlling system-wide privileges in Unix-like operating systems. PKExec is a component that provides an organized way for non-privileged processes to communicate with privileged processes. This case is interesting because malicious abuse of the PKExec command line arguments in its default configuration settings can eventually lead to the Linux kernel, rendering any unprivileged user process full root privileges on the vulnerable host. At the core of the matter, it's rather easy to maliciously design a shared object that runs as root to do just about anything, and the exploit presented in this demo will just open a new unpermitted root shell session, bypassing all built-in authentication, authorization, monitoring security tools, and policies. Towards the end of this video, we will show how the Morphisec Linux protector, also known as Morphisec Knight, stops the untrusted shared object sideloading exploit presented in this demo. We will then switch the Morphisec Linux protector into a blocking state. This prevents attackers from exploiting well-known Linux APIs and services, and in this case, blocks the creation of a new shell process forked from the untrusted library or shared object. And in respect to the demo case, it will work just as well for other protected APIs and services, such as open, read, write, memory allocation, permission resettings, and others. Beyond the attack log, blocking means the protector blocks the attacker's call before reaching their desired objective. In Linux, it is permissible to call mprotect on any address in a process's address space. It is an interesting test case because it can be used to change existing code mappings to be writable and executable. And from the protector-generated attack log, it is possible to realize that the protector saw this request coming from processes having an untrusted library, thus marking the entire process as untrusted, with clear indication around the call stack, untrusted library source, the protected API trapping, and more. From a broader perspective, creating processes, allocating memory, and altering permissions happen all the time around running processes. Locking those services down against unauthorized abuse is extremely hard to achieve, given current-day security tools and hardening possibilities. As this demo presented, moving target defense and ongoing trust module monitoring make it much harder for an adversary to successfully run an exploit over a reasonably hardened system. Think about how hard it would be for adversaries to exploit those exact APIs when their actual table references are randomly selected and periodically changed. Find out more today by visiting www.morphisec.com.